Okay, so picking up after our last video of angular velocity, we're just going to pick up and do a quick review problem, and then we're going to move into more complex velocity problems and acceleration problems. So we're really going to have to use some pre-calculus skills to get through. Okay, so for this one, really quickly, a ball rotates at 2 pi radians in 4 seconds. Okay, so 2 pi radians in 4 seconds. Okay. And I want to know what the angular velocity is. That's our question. So we just wrote our givens down. We have time, and we have our radians, or our distance in this case. Okay. So the way you could look at this, there's different ways you could look at this. This is angular velocity. Okay. So this is really, it's really this circle. Okay. But now I take a look at this and I say to myself, okay, well, circumference is equal to 2 pi r, right? Which is really just the distance, the very distance of this outside of the circle, right? It's following where you'd put a tangent line on the circle. It's following this all the way around the pivot point, okay? So 2 pi r. So who's to say, while I'm looking at this, I'm thinking in my head, I'm picturing to myself, okay, well, that's our outside of our circle, 2 pi r. How come I can't just open this circle up? And it's the same thing if I do open it up. So for instance, I take this wire, right? I have it wrapped around in a circle loop. When I open it up, there's my full distance from my one finger to the other finger, right? So when this is wrapped up, it's the same thing. It's really the same length. It's just in a loop, okay? And they're trying to trick you in this case. They're trying to make it more complicated than it really is, right? So really here is what we're looking at, just opening this up into a loop. So if this is 2 pi radians, right? In this case, it's 2 pi radians. So I know that half a revolution is pi and a full revolution is 2 pi, right? Because 180 is the conversion factor. So this would be 180 degrees. 360 degrees is 2 pi, so that's 1 full rotation. So if I have 2 pi, right, in 4 seconds, it's simply going to be 1/4, right? It's going to become 1/4 because I do 2 over 4, right? I wind up doing 2 pi over 4 seconds, right? And I'm winding up getting 1/4, right, of the revolution. So it's really equal to 1 revolution, which is really 0.25 radians per second, right? And this is very visual in this case, right? And that's your answer, because it's very visual in this case to the point where you're looking at the fact, and make sure it's in radians per second because it's units of velocity, but it's very intuitive, you could say. It's very intuitive, this stuff. You lay the circle out and it's like, that makes sense. This distance to this distance has to be equal to the whole distance around the circle, and it's very, very true in this case. So my radius is 0.25, right? And I plug in my calculator, 2 times 3.14, you could write pi, whatever, times, let's say my radius is 2.5, right? 15.7 is my length of this line right here. This line is 15.7, as well as the whole distance around the circle would be the same in this case, okay? So that's that. So that's a good way. I like explaining it that way. It's very, very intuitive, and I think it's very important that we all get a grasp of it in different ways. Okay? So now, very similar, we want to use one with an arc length now. So we have a circular path of 0.25, right? And we want to find, so we have a radius. If we're given a radius of 0.25 and an arc length, right? An arc length of 0.75, right, and we have 8 seconds as our time, we want to find the angular velocity, which is W once again, okay? So in this case, we could use something very similar.